Hello, welcome to Why Oil Analysis. My name is Mike Hitchcock. I work for Acorn Petroleum. I work with the oil analysis program here, and I've been working with oil analysis for the better part of 20 years. And I'd like to share some of my insights and some of the things that I've learned as to why people should use oil analysis. Now, today's theme is you can't go back and change the beginning, but you can start where you are and change the ending. It's a quote by C.S. Lewis, but it's very true. You can't go back and change the past, but you can affect the future. And that's what oil analysis, tries to do, is change the future. So let's look closely at oil analysis. Well, who are we? We're Acorn Petroleum. We're a Chevron distributor, Baldwin distributor, a CFN marketer. We work out of multiple locations in southern Colorado, service a large portion of Colorado. And But there's, we work in a wide variety of fields, from mining to manufacturing to municipal, and everything in between. So, what is more cost effective, free oil changes or an overhaul? Or is there another option? We've all seen the commercial with the LifeLock commercial where the bank is being robbed and the people ask the guard if he was going to do anything, and he goes, "Oh, I'm not a guard, I'm a monitor." And, well, what's the monitor do? He goes, "Well, I tell you that you're being robbed." And then he goes, "Oh, you're being robbed." And that's a lot like what we find, how we find out that there's a problem is when the problem is already surfaced and it's too late to do something about it. But what if there was a way to determine when fluids needed to be changed, what fluids needed to be changed, and what maintenance is needed, and if a maintenance action could be delayed, prevented, or even eliminated? Can we see into the future? Can we prevent serious damage? Can this knowledge make a difference? Of course it can. So let's take a look into the future. Losses to poor lubrication practices. An MIT study showed that $240 billion in repairs, downtime, and equipment in the United States alone. It's losses, money that was lost, basically because of poor lubrication practices. Well, if we could fix those, we could save billions of dollars and improve our basically the health of our companies multifold. This is something that oil analysis does help to do. In most situations, there are three maintenance modes. There's run to failure, preventative maintenance, and predictive maintenance. Run to failure is most often seen in gearboxes and hard to service components. It's in things that are difficult or almost impossible to maintain and inspect. We change them if we can. We replace the components at failure. That's basically how run to failure is managed. Most companies operate in this mode somewhere in their organization, uh, and sometimes by design, because it's out of necessity. Preventative maintenance is dad's way. Change the oil at 3,000 miles, that sort of philosophy. We lose resolution. We still don't know what's happening with the component. We don't know what's going on inside the machine. I call this the pay and pray method. It's not our fault. We've been programmed to do this over the course of our lives. The owner's manuals in cars have the back pages are filled with little check boxes that you fill out if you did your oil changes every 3,000 miles, and did you check the fan belts, and you do all the different things that you were supposed to do in a program maintenance fashion every so many months or so many thousand miles. But there is a predictive maintenance model. And that uses analysis to discover what's happening with the component, looking for wear elements to determine if there's a pending failure, and learning what the lubricant condition is at the time of the sample. We're determining if any additional analysis is required. And if we put these modes on a bar graph, we run from run to failure to predictive maintenance, run to failure being the most costly, and the predictive maintenance being the least costly, and program maintenance floating somewhere in between, depending upon how it's managed. The problem is that with the run to failure, you still know nothing about what's going on with the component. And with predictive maintenance, you have a pretty good idea of what's going on and where you are, where you sit with that piece of equipment. So in predictive maintenance, once we have a history of analysis, we're able to determine the trend of the asset. Basically, we develop a normal. And in this normal envelope, we can figure out where, when there's changes, we can determine what's going wrong with the component. And from there, we can start saving lubricant and reducing downtime. And we do this by using the exact same tools scientists figure out how the universe was made, what the universe is made up of. Just like your doctor orders blood work before you go in for a physical, this tells them exactly what the state of your overall health is. Chances are they can tell pretty much everything except about, without knowing your temperature and your heart rate and things along that line. They can tell pretty much anything that's wrong with you from a blood test nowadays. We can do the exact same thing with an oil sample. We can tell a lot from an oil sample as to what's going on with a piece of equipment, and without doing a physical examination of the equipment itself. And we can see what if there's what the condition of the oil is. We can determine what the state of the machine is, and we can find out if there's any external things getting into the machine. When we analyze in-service lubricants, we gain an understanding of the overall condition of the fluid. And like I said, we can look at the elements of the fluid, determine if the components may be wearing out, if there's contaminants getting in, and if we need to replace any parts or pieces. So if we look at this is the bathtub curve. And what's nice about trending is we can trend in the fact that there's a break-in period, and we know that there's going to be some anomalies in the oil samples during the break-in period. But once we get past that, everything flattens out. And it stays pretty consistent throughout the lifespan of the equipment until we get to the end of life. And then things start going awry. So it's during that time when we can look at all these different, look at that flat line, that becomes our normal. When things deviate from that, we know that we have a problem. So we can extend the useful life of the equipment by maintaining the flatness of the curve. And we can also determine when the equipment will be need repair or total replacement. This helps us to reduce in-service failures. There's nothing worse than a piece of equipment failing when it's needed most. We can reduce equipment loss or component loss. And then we eliminate waste, time, and the uptime operation, increase the uptime operation. Those are the things that we are really looking to do. We've talked to a company that was 25 pieces of construction equipment. We saved them over $20,500 a year by increasing drains from 250 hours to 350 hours, just by doing that. But the other thing, the side benefit of that was we were able to give them insight as to what was going on with their equipment and prolonging the life of their equipment by eliminating some dirt intrusion, things along that line. Over the road trucks, we saved a company over $11,000 a year by pushing their drains out. Again, this was just in the cost of the lubricant. It's not looking at the cost of the hourly wages of the employees that changed the oil, things along that line, the downtime, looking at loss of service, and we gave them a little piece of insight as to what was going on with the equipment. I had a construction company that we showed them that we could save them $1 an hour on their operational costs per piece of equipment using oil analysis. And by doing that, the company just looked at us and said, we just won every bid we ever participated in because that's the difference. That's the difference. That was the key. And they embraced the oil sampling program, and they still are doing it to this day. We had a plant, a production plant that we were working with. They were able to, because of oil analysis and using oil analysis in their machine operating machines, they were able to plan for an outage that was going to occur. They had a piece of equipment that was going awry. They had a holiday period that was coming up. So they managed to shut down the line during the holiday period when everybody was gone, keep the millwrights there. They repaired the equipment while during the holiday period, saving the company thousands of dollars of downtime. Having employees there while the machine was down would be devastating. But they were able to program a maintenance evolution during a holiday period. This was a lifesaver for them. So when we manage equipment or component life, we know what wear elements are in the oil. It gives us a heads up. If we know what the wear elements are in the oil, it gives us a heads up of what's wearing out in the equipment. And it gives us an idea of when we can predict maintenance. Knowing the condition of the oil lets us determine the health of the oil and determines whether the fluids need to be changed. One of the things that just bothers me the most is that people probably throw away perfectly good oil, thinking that because it's 250 hours old or that it's got 3,000 miles on it or whatever, and they really are throwing away perfectly good oil. This is a big savings for a lot of companies when they look at this. We can extend drains, we can increase the uptime, lower costs, increase productivity, and eliminate waste. And we can also predict your downtime. That puts maintenance on your terms. That's very important. Talking to an 80 vehicle bus fleet that had drains at 4,000 miles. We were able to, by using analysis, we were able to increase their drains from 12,000 from up to 12,000 miles, and that saved them $32,000 a year in lubricant. And that their uptime increased by 20%, and their tows reduced by half because they could see into the equipment and they knew there was a problem before it reared its ugly head during a route or something along that line. Using oil analysis, you can pinpoint failures without tearing down the entire machine. There are types of, an oil analysis itself is more like a CT scan of the equipment. But there are other types of oil analysis that are like MRIs that we can actually pinpoint right down to the component that's wearing and why it's wearing. And that eliminates expensive trial and error repairs, throwing parts at equipment, things along that line, or doing just a minor tear down as opposed to a complete tear down to find out what's wrong. The other thing that we can do with oil analysis is find intrusion points. Find out if there's other outside contaminants getting into the oil that will cause problems. This will reduce failures in and of itself and prolong the life of the equipment. This is a life extension table that we use, and it shows that if we take the cleanliness from one point to another point, if the current situation is say a 2017 cleanliness code, and we bring it up to a 1613, we've increased hydraulic systems the life of a hydraulic system by 3 times. The vast majority of these things we can do just by doing looking at intrusion, finding out where the contaminants are getting in the first place. We had a construction company that discovered a source of silicon intrusion using oil analysis. We found out where the intrusion was. We isolated that, and then we looked at the entire system, added a couple filters, and we brought their cleanliness way down. Literally, the pumps in that piece of equipment will never wear out at this rate because of the fact that there's hardly any contaminants in the system at all. by looking at an oil sample, and we can see that there's an abnormal reading on the oil sample, we can go straight to where the comments section. Most all the oil analysis companies that we work with have massive databases of equipment and problems that can be realized. So what we do is they have a database that say they see these particular parameters showing up. They can almost point to where the failure is, or where what needs to be looked at from the very beginning, saving the repair people tons of time. Again, looking at the trouble points, this gives you an idea, data showing that the lubricant's getting thicker. Well, if we know that the lubricant is not in the world's best condition, it may need to be replaced. This, in this particular case, the thickening of the oil would cause additional friction. It would do more damage to the equipment than help. So what do you consider in an oil sample program? What are your goals? To reduce downtime, reduce costs, increase uptime, increase profits, all of them. What are your present capabilities? What are your equipment requirements? Do you have to train people? Do you need parts, pieces, infrastructure? And how will you track your progress, the KPIs? Is there software? Is there staff that you'll have to add? And what are our expectations? What are your short-term and long-term goals? And what are the historical considerations that you have? What have you lost in the past that you'd like to prevent in the future? We always say to set realistic goals. And where do you start? Well, it starts with a pretty good understanding of where you are. How do you get training? Understand that consistency is the key in everything. Look forward to the goal. Buy-in from everybody involved. Everybody in the company has to buy into this process from the beginning to the end, and continue to improve. And I always like to take the hint from every shampoo bottle ever made: rinse and repeat. So only you know where to start. Most start with their most expensive problems and work backwards from there. And that's usually the best way to go. Do you have where do you start? What are your capabilities? What do you have? Do you have oil sampling equipment? What laboratory services do you need? Do you know what kind of training do you need? And how are you going to keep on the right track? Well, basically, the oil sampling equipment, for the most part, is just a vampire pump and some tubing. It's not that expensive. The laboratory services, well, it starts with the good lab and it ends there too. I recommend that you work with STLE OMA1 minimum staff, that they should have OMA1s on staff as a bare minimum. CLS, OMA2s are preferred. There's other certifications. There's MLTs, CMFs, and things along that line. Those are very good certifications as well. That they have online services that you can read your reports online. That they have training and support. Many of the labs that we work with have online training sessions and things along that line, or resources that you can download a video and that sort of thing. Telephone support and local representation. What do we need to know? Well, what kind of training do you need? Taking proper samples and understanding the results. Acorn Petroleum has training in all of those things. We can train your people on how to take the proper samples, and we have an extensive training series on how to understand the results. And with very minimal time invested, we can get you up and running with a very, very effective oil sampling program. So it starts with an independent survey, assess where you are in the process. Equipment lists, we need to start seeing what your equipment is. The equipment name, the compartments, the fluid types, that sort of thing all has to be categorized. And then we make the call. My name is Mike Hitchcock again. I'm a CLS and an OMA with Acorn Petroleum. I'm here to help. This is my phone number and my email address. Be more than glad to help you out. Anybody at Acorn Petroleum can point you in the right direction. We're here. If there's any questions that you have, please feel free to contact me. And I look forward to working with you in the future. Thank you very much.